Well, let's try this again. It didn't record there. So anyway, here we are in the middle of section 2, chapter 2, with sections 2.4 through 2.6 on the stack interface and how that works. And we're going to get into array bounded stacks and all. And so I want to talk here for just a minute a little bit about um, where things are and all that. So I have put out on to Moodle the PowerPoint slides from the book for chapter 1, chapter 2. But also I've included here in the top of our lecture here for this week some screenshots just showing the book files there that you can download. As I say, I sent y'all the correct link on that, and so that if you download and extract those book sample data files, code files, and all that, you've got files for each of the chapters. Chapter 1 actually has a couple, and some other things. And then if you click out on like CHO2 of that, you have 5 sections, apps, and then the code for the balanced, which we'll get to at the very end of this section. It's got a thing prior to this for those figures, drawing that figure thing. And then you've got a thing for postfix, which we'll get to in the next chapter, sample code and sample data. And then the last one is stacks. So if you click under apps, then you see that you have code for this balanced expression, which is in the last section here in 2.6. You've got a postfix and all graphical user interface and CLI. We'll get to postfix next week. You do have a thing for reverse strings. We'll mention here in just a minute, but the sample code there. And for all of these programs now in the book, I'm also going to try and include their code here in the lecture notes and all that for you. But you got a couple of things there. You've got the stack driver at the bottom 97 we'll talk about, and then we get a little bit into test data. That's what that test 034 code is there under the apps one. And usefigs, we are not worried about it right now. So you look at that under CHO02 apps. If you go out under stacks there under the CH02, then you've got sample data there for the array bounded stack, original on 92, and then updated version on 100, and array list stack on 100, and we'll talk about linked list, and then it's also got a thing for a stack interface on page 100, and underflow and overflow exception codes there. So as I say, a lot of these codes that it talks about are here in the programs in the book. Then I've got the sample code for them included here in the lecture notes and all. So as we get into 2.4, it starts talking about the stack interface, how to deal with stacks and their implementation using arrays. And as I say, next week we will get into linked list. And it certainly looks like that there are a lot of wonderful built-in things in Java to handle working with linked list. But we talk about abstract data types, and, we've talked about there in section 2.1 about what type of elements it'll hold, what types of operations. So we mentioned a stack is of LIFO, last in, first out, only works from the top, and you can push items onto it, you can pop items off, you can look at the top. But you gotta, in all these cases, remember, deal with an exceptional situations. How are exceptions handled? Do you handle the error within the method? Do you throw an exception type of deal, or do you let the system handle it? So, there are ways you have to think about. And really, most of the time, most of your errors will be if a stack is empty. Do you have a new stack and you're trying to pop something off of it without pushing anything? Pop could do nothing or top could return a null. You might at the top of every operation, and it does have some sample code here about check for an empty stack before operation, where and how. And when do you do that checking? Do you let the abstract data type do it itself? And so they've got, like on the page 86, this code for is empty Boolean up at the very, very top. And it says my object equals my stack dot top. So that works, but it has to be invoked every time, if that's true or false. And maybe the better thing to do, like it shows on the bottom there of 86, is to throw a stack underflow exception. And so there's a thing there where they declare a stack underflow exception and all of that. And if that works, then it extends a runtime exception. So you have stack underflow, and it has then where it uses some code there and creates a public stack underflow, where on the top there of 87, where it's either it could be a system message, it could be a simple message where it attempted to on an empty stack, or you have another set of code there with a message there that says notify system control, an exception has happened. So, you can have different types of messages, or it then talks about, well, what happens if you try to push on a full stack? Well, that's really pretty well impossible. Unless you run out of, if you're doing an array, if you try and push something like to the 101st element and you only have 100 elements cells in the array. But, you might have to, that would be your main check for a overflow. Because these days you have a relative unlimited amount of memory on the computer. When I first started programming, I had a TRS-80 Model 1 in my dorm room at Tech in 1980-81, and now we only had 64K of memory on that, so we had to be very careful on those early programs. But, as the first PCs came out with 256K and all of that, well, we could do a lot more things. But as we talk about, to make sure you don't run out of space on an array-based stack, maybe you use an array of arrays type of deal. So you might have, like on the bottom of 87, where it has this public class overflow exception that extends a runtime exception type of deal to send out a message. And so you have those things, or you have various interfaces. You've got some sample code there that you can certainly look at on 88. And that sample code uses, remember, that placeholder for the collection of elements that that less than t greater than t, where that it handles that stack interface, and you declare S to be a stack of strings. So there's a real good example on the bottom of 89 where that they give the initial program just 3 strings, and you enter them in, and then the program pushes those 3 strings onto the stack using a for loop. And then after that, there is where you see a while loop while the stack is not empty. Then it brings the string back to the value of top, and then it pops it, prints it out, and just does a simple reverse loop like that. So it relies on the package of programs, as I say, under the C802 apps. So, as you're working with bringing some of these codes in, I haven't given a program yet. I will. Spent some time with Dr. Whip Watson this week and Philip Kilgore on how all that works. Y'all are going to certainly have a lot more knowing Java much better than I do on how to handle some of these runtime interfaces and using the different types of coding IDE to create and bring things in. So I'm certainly not gonna, emphasize a lot of that, but I want to make sure you have some good things on theory. We're going to talk here in a few minutes. I've got a couple of stories about validating data, things like that. So that's why I want to make sure that you know where that C802.apps subdirectory folder is and all that under that master book files or whatever you want to call it. But, make sure that you in your code, it knows where those are in the same subdirectory, things like that. So, simple. Enter gives a, if they're on 80, on 90, gives a message to the user to enter a line of text. The scan function brings it in, then it pushes that line, increments the counter, and then, as I say, once the counter is equal to 3, then it goes down to the while loop, while the stack is empty, and then it pops it out and prints out the line there that they entered of just text type of deal, beginning of the story, etc., etc. So you do have those things there. So then we go to section 2.5 on array-based stack implementations. And as I say, they really get into this a little bit on implementing an array. And remember, Java begins arrays at 0. So when we normally think about array, the first cell being a 1, subscript 1. So a lot of times as you're thinking about things, you subtract a 1 from the index or element to give the true memory location. And as I say, they talk here with a little bit of code on the top of 92 about a variable called def, DEF-CAP, default capacity. They set that to 100, and that just says, okay, the most number of entries we can have in our stack is 100. And so they create it and then allows it, or there's another one where the default program can specify the total number of elements, things like that. And so it just works its way through, popping things, pushing things on top. As I say, if a stack is empty, there at the bottom of there the code, then it throws a stack underflow exception, or underflow if it's empty, and type of deal. And there, if you, let's say this takes several pages, but it's kind of got here on the middle of 93 where it's got returns if stack is empty. There, that Boolean return top index equal minus 1. That code's kind of covered on page 93, but it's really only, if you look at the program, it's really at the very bottom of the program. So kind of the book here on 92, 93, 94 kind of is a little bit out of order, but not really. The whole idea is there on working with the code. So it shows there like on the top of 94, a good practice where if you pop something, put a null in its location. There on the middle of 94, pop. If a stack is empty, it throws an exception, otherwise removes the top element. And then bottom 94, top 95 returns the top element of the stack. And then it gets into a little bit about application view of implementation view or abstract view. there's kind of the chart there on the bottom of 95 of just saying, okay, well, if we're looking at the application side, well, that's the code as such. Or if we look at the implementation view, that is where I like to say the old term playing computer. So you notice there you've got 3 elements on the in the array. There's nothing there. You come across there middle of the way down where it says mystack.push_a. Well, then notice on the middle code it's showing there that an A is going kind of into 1. And cell number 1, or actually cell 0, remember we start off at 0. And then it's just saying the abstract view, well, top has an A in it. Then we're going to do mystack push B. And then, so you look there, you see you got A, they are pointing to A and to B. And then you see what it looks like. So, it's certainly some good practices. All that. Chapter 96, it talks about queues a little bit. I mean, page 96, it talks about queues a little bit and instantiated arrays, and we'll get to that in another few weeks. So, but I want to talk about testing especially, and this is something that Dr. Watson, Philip, and I were talking about earlier this week. And there's so many famous examples, unfortunately, of where people didn't properly test a program. And there are famous ones you've probably heard about in other classes, like one of the space shots, where one half of the group was dealing with meters and another half was dealing with feet, and neither one knew what the other was doing. And so a rocket, wound up going all out into space in the wrong direction, or used to have. There was one with one of the mirrors on, I think it was on Hubble, and they had to go back and regrind to replace the mirror on the Space Telescope because of some problems with testing. But if you really look at the programming process, the 6 steps, and the first thing that has to happen is you as a programmer have to analyze the problem. What does the user want this program to do? And then you look at time, you look at inputs, you look at outputs, all of those things. You look at where data is coming from, how's it going to be entered. And here towards the end of the chapter, this section, I should say, they get into talking about, well, so many of the programs up until this point in the book have been just command line driven. And that's weird for me. So, and they finally get into, well, we could use a graphical user interface. And so they show some code here on a couple of these programs that's end with GUI type of deal rather than CLI for command line driven. So you analyze the problem, you look at designing the solutions. You don't hear much about flowcharts or pseudocode, but you certainly look, really you have, we talked about that universal code, the unified method, UMI type of deal of, defining your methodology and all that. Well, and that's really almost like there with that unified modeling language, UML, almost like the old days of flowcharts. So you write out graphically what your logic's going to be, where things are coming from, where things are going. And then the third step, you validate your design. And with that, you go through and you play computer. You actually go through all of the steps in your design, maybe even if you've written out the code, to make sure you haven't missed something or otherwise. And then the fourth step is you implement the solution. Maybe you choose your right language. And that's one thing that I tell students is, the more different languages really the better your choices will be. Because back when I first started, well, I mean, one semester I was working in 6 different languages. I was doing Fortran for science, COBOL for business, PL1 basic, assembler, and RPG, which is actually still around as a programming language. Some of y'all know Leslie Rogers, who teaches for us adjunct. Leslie is a RPG programmer at Morris Dixon, drug distribution down, South Uri from us and at the port. And so you implement your solution. You choose the language that has the features for what you need it to do. Or maybe you don't write a program from scratch. Maybe you use a package or whatever. So that's the 4th step, is you implement the solution, and then you test your program as the 5th step, and then you document. And really, testing and documentation really are not at the very end. They're an ongoing part of the 3rd step of implementing the solution. And then just remember, folks, once you get a clean compile of your program, does not mean it's right. And that's a mistake that so many people make, is they think, oh, well, the program compiles, it doesn't have any errors, it's got to be right. Well, that doesn't allow for logic errors. And I teach a lot by stories. And one of my favorite stories I've always told, the 111s, the 115s, happened back when I first started teaching. And as I've told y'all, I spent as such 9 years on your side of the desk at LSUS, and then in '85 started teaching. And student evaluations. Well, back when I was on your side of the desk, well, oh boy, that's 30 minutes less of lecture today. And we didn't know as students what happened to them. But I got on this side of the desk, and I start getting these reports, and every faculty, we get y'all's evaluations the following semester after the semester's over. And I've always picked up some good things from the student evaluations. And but I also used to get some weird things. One time I had a student back when I was full-time, and I wore a tie to class, saying I ought to get married where my wife could help me keep my tie straight. Well, whatever. That never happened. But if you think about the evaluations you fill out, and you notice there that you have the rating scale from 0, I guess, to 7, and it's called a Likert, Likert scale. And anytime you're doing from strongly disagree to strongly agree, you always want to allow for one in the middle, a not applicable, neutral, things like that. And another thing you always want to do on Likert type rating scales is to allow for some negative questions, so it slows the person down who is filling out the questionnaire, where they will go through and read the actual question. And so those are just good. And then there's also the type of thing with the short answer questions type of deal. And I always used to get real good comments from the students, but my numbers were so-so. And after a few years, one day, Dr. Wilfred Guerin, who used to be provost, vice chancellor academic affairs, number 2 person on campus, called me one day and he said, Claiborne, come over to my office. I need you to look at something. When the number 2 person on campus tells you to come to their office, you can say, how soon do you want me there? So I went over to his office, wood grain, bookshelves, comfortable chairs, beats the cinder blocks most of us have. But he said, Claiborne, have you ever looked at the student evaluation program? I said, well, I helped Dr. Mike Clarity. He and I one night looked at something on it. Otherwise, he said, Claiborne, I get great comments, but my numbers are so-so. And I said, Dr. Guerin, I think you're right. And so he said, figure out what's going on, let me know. So I went down to Computing Services and got with them, and they had used a student grad assistant had used a program maybe some of y'all have used in some math classes or otherwise, called SPSS, Statistical Package for the Social Sciences. It's kind of like SAS or R, a package where you don't have to write all the statistics. It has generate them for you, descriptive statistics or proc means or whatever. Well, the person who had written the code to analyze the questions had made a mistake in the code. One if statement was wrong because, as I found the code, instead of reversing only the negative questions there to make them positive, the ones that were worded backwards, which is very good test practice, all that, he had reversed all the questions. So then if you really did the math, it moved everything to the middle type, where everybody was getting a 3 rather than a 1 or a 7 if they were great or not so great. So it took me a while to find it. So then I went over to Dr. Guerin's office and explained it to him. And he sat back, and I say, remember, he was former professor of English, but I'm not going to say what he said. But he said, Claiborne, you realize we've been using wrong data for years to evaluate faculty? I said, yes, sir. And I mean, heck, when I first started, one of my office on the second floor there, Bronson, by the science dean's office, and that's also the English department, and there were bad things written on the faculty restrooms about one of the English professors. And also, he said, can you fix this thing? I said, yes, sir. So I wrote several hundred, probably 500 lines of COBOL back then. But once I got a clean compile, then I started testing this program. And I made up test data for it just to, and I had some classes where the instructor was absolutely wonderful, got all strongly agrees type of deal. I had some classes with all strongly disagrees. And I made sure by hand or otherwise that my program gave correct information type of deal. So you've always got to think about when you're writing a program or a package, whatever, using a spreadsheet, using a database, it doesn't matter to me what you're using, but you've got to make sure that the results make sense. And here for years, you had all of these, quote, smart people who were getting these wrong results, but nobody disagreed with a computer back then. So coming up with good test data is such an important part. And it talks here a little bit about here on using top of 99, where they are pushing up to 34 different cases or values onto this array. There's some discussion about professional testing, all of those things. But just because a program works doesn't mean its results are correct. So you've got to use good test data, but also documentation is so important. And one thing I like about the text in your book, excuse me, all of the sample programs is they have some good comments generally at the top of all the sample code. And learning to comment your program, not only at the top, but also throughout the program is very important. Test the parts as you're creating them. Maybe you just have, a half a dozen lines of code of testing a push or testing a pop type of deal, are so important. But integrated testing, test them as they're doing it. I tell the story about years ago, the city of Shreveport had a program and they went to make a modification to it. And of course, as y'all all know, programmers are a group or class of employees that move from place to place. And so this programmer for the city for the documentation just said, "See me." Well, the problem with seeing her was that she had moved, I think I heard, to Alaska, so the city had to rewrite that program, again, because of not proper um, documentation. But, your initial test might just be, okay, does this set of code perform or not? Does it compile or not? It talks about the bottom of 96, but they also talk here on 98. Well, what are some possible errors that can come through to allow for, with pushing? Well, should it? Uh, what happens if you push onto an empty stack? Does that work? What happens if you push onto a newly empty stack, or your pointers indexes where they need to be? Or you push onto a stack with only one element, or you push onto a full stack. What happens? Or an almost full stack. You know, Maybe there's room on the stack when you pushed onto it, but then afterwards there's not room. Or you push onto a stack that was full but has only one empty slot. So there on the top, as I say, bottom of 98, top of 99, they talk about professional testing and how they're groups that, multiple tests for all different possibilities. As I say, batch testing programs or suites. And they talk there at the very bottom of the gray part there in the middle of 99 about this information about JUnits. And it's a testing framework at www.junit.org. And so, it's certainly we're seeing testing and all that becoming more of a thing to do because of needing more and better programs. So, as I say, just kind of always think about how you're going to test your program, how you're going to work with it, and otherwise. And then the very bottom here, we get to 99, where it uses this alternative abstract data type Java class library, talks about different ways to using this array list stack class, which can grow and shrink as need be. And the top is always the size -1. You don't have to worry about stack overflows. And so you have a little bit of code there for that. But as I say, you're just really talking about, well, what happens if you might run out of room, which certainly you shouldn't. So a little bit of code there on returning it if it's full. But then we get over to 2.6. And 2.6 talks about balanced expressions and talks about how stacks are great for remembering things. And so here, this sample program that they create here in this section, they're looking at your grouping opera symbols, parentheses, brackets, or braces. And you've always got to look at, okay, if I have an open parentheses, bracket, or braces, do I have a closing one type of deal to match? And so, whether we're doing lengthy math equations, whether we're checking the syntax of a program, I don't know if any of y'all ever have taken or will take the old compiler construction program. And, I think that was 400, CS 400. You certainly had to worry back then about, how a compiler works. How does it know it reaches an end of a line? Well, type of deal. So we'll talk more about that in a minute, or XHTML tags. So it talks about there, like on top of 102, you've got on the left under well-formed expressions, you have like parentheses, XX, parentheses, XX, open parentheses, then close parentheses, XX, close parentheses, where on the other side you're missing uh, parentheses type of deal, or you got the wrong brackets there on the right side. So, everything adds up or doesn't. And but they create a um, idea of a class called balanced, and then that balanced class uses a method test and returns either a 0 if it's balanced or 1 if it's mismatched, if it's doesn't have a close to match and open, and it returns that integer value 2 if it's a um, um, missing a close symbol. So, you got to think about, folks, a missing semicolon in the case of Java. Other languages use semicolon. That's pretty popular. The first structured language I learned, PL1, Programming Language 1, it used semicolons. Of course, before that, I'd learned COBOL, and COBOL ended with a period. And, folks, I tell any of my classes, y'all don't ever be concerned about if you make a mistake. The in-person classes, I tell them, look, I'll maybe kid you a little bit, but there's not anything y'all can do that I haven't done. And somehow this was in the old days of cards, and you only got one run a day. Well, somehow I didn't know in COBOL, or didn't remember to put periods, because I didn't have to do that in Fortran, and I left off all the periods. So I got back the next day, and my 75 lines of COBOL had generated 200 lines of error messages because I left off the periods. And so I had to repunch all those cards. But you think about a stack, as I say, as a way of going through and saying, okay, well, is there a missing close symbol? Or, if we're looking more in a compiler situation than a math operation, whatever, is there the ending marker for a line of executable code? Looking for that semicolon. So, you've got to assume here that the conditions are met. We've talked about, programming by contract, where you assume the preconditions are met, and it looks at each character of this string, this expression. And if it's an open symbol, it's pushed onto the stack. And if it's a closed symbol, then it looks, okay, we have a closed symbol coming in. Let's look at our stack. If we got a closed, do we have a pop? Do we have a open at of a similar type at the top of our stack? Well, if we do, if they match, it continues to the next character. If the closed symbol doesn't match the top of the stack, or the stack is empty, then it'll display, print out whatever, that the stack is ill-formed, or if it's a character is not a special symbol, then it's ignored. So it talks about here on 104 about there being 6 different possibilities or conditions. And it says, well, if the stack we're creating, we declare our stack interface, but instantiate it as an array bounded stack. Or we have to look at the length of the expression. Okay, well, depending on the length of our expression, that's the maximum number of items we can have on the stack size. And so they're pushing the position. Notice they're not in the code pushing here. And this is a code that starts here on 105 and works its way over here for a couple of pages through 107. As I say, that's going to be CHO2 balanced is the file. And so it's looking okay. It says, okay, if they're pushing not the actual symbol, but the location of it in the string, the position of it. And then I say it pushes that. It talks a little bit something called autoboxing, which is a Java construct to convert an object there, in this case, a counter into an integer. And then they have the backward side of that to, if it's a closing symbol at the top of the stack, if it's empty, and that means that they've encountered a closing symbol, but if the stack is empty, then it's a stack underflow. And then at the very end, it looks to make sure the stack is empty. So you have the code there with to look at it and opens it up, type of deal. I say a little bit of commenting there about, what it returns. I say very good practice right there in the middle of the code there, top of 106, saying, okay, it returns a 0 or a 1 or a 2. And then a little bit there about inline commenting. And that's the thing I do like about this language, is you can put comments there with the / on a line of code as to what it does. So, is it the index of it? Is it getting a character? Things like that. Looking on down to see if we've hit the end of the stack. Otherwise, it pushes the item out there. And so, some very good program examples here with this one type of deal. So that's why I've included all of it in there. As I say, several pages here in the notes, just where you have it there also. And as I say, then it talks about the application there on 107. And this is something that to me is kind of weird. He's talking about command line interface, CLI. And to me, that says, hey, the user has to, when they run a command line to run the program, they've got to supply arguments at the top of it. Hold it. We aren't, that's something we would have done back 90s, system control on IBM mainframes. So they talk about here on moving from that command line interface to actually having using a graphical user interface, a GUI. And as I say, it finishes up there on 109, just where you have the expression. It prints it back out, whether it's balanced or unbalanced. And then they say, well, hold it. There's a better way of doing things. And that's the graphical user interface there to implement. And so we finish up where it checks for it, all of those things, but it imports it in. You look at the appropriate commands there, whether it is good or bad type of deal. And so you have those lines there. And I just noticed a change I need to make here. 107. We'll say 109. And so then you get here where it talks about the actual commands there to implement it under the GUI. And that makes a whole lot more sense, where it's actually using the setting it up, print expression, and type of deal. So that's how it really kind of finishes here, is, as I say, with the actual GUI implementation. And so you have the CL1 there on 107 through 109. And then it talks about the CLI. And then I say you get into the GLI type of deal. So you have the CLI code. Then, as I say, you see the graphical interface, and it doesn't print out the full code, but I say you do have the code for that, the graphical user, as a file under the CH02 folder subdirectory. So certainly look at the actual code there. Say I've got it here in our lecture part, where you go through, it imports things in, it talks about borders, and I'm not sure how much y'all have done in the way of graphical interfaces or otherwise, but you do have there about 3 or 4 pages of code where it talks about sets, groups, of symbols, creates the resulting code, as I say, 0 for balanced, 1 for unbalanced, 2 for premature end. And then you look over at it has using buttons and frames to display the what it looks like, setting the size of it, horizontal, vertical sizes, and then enters the value where it tells the people enter the expression right here, and it's allowing up to 60 characters. Then it has a result of the status. Then it does evaluation, has buttons there with this action handler. And I assume y'all have done some of this otherwise. And then instantiates a content pane and expression panel. So it shows the display, and then the button, push, things like that, move things up, down. And then finally, it shows at the very back there of 2.8, figure 2.8, the modeling language, and that is kind of here. But I say just some good notes there on how it works, things like that. But main thing with stacks is a lot of the work the programs Java code is going to handle for you, so you don't have to do uh, a lot of work to do it. And so just keep at it. And as I say, I'll post some assignments for y'all, and we'll get into linked list. But this gives you a simplified way of working with stacks as arrays. As I say, you get used to pushing and popping, all of that. And so just have a great week. Call me with questions. Be careful. And I'll keep putting stuff out there for you.